Yes, good day, class. Welcome to Metric Hub. Today we are going to be looking at a continuation of our previous chapter, Haematology. But we are looking at red blood capsules, the erythrocyte count. So what you need to understand is that uh, we are still looking at blood, the start of blood. We are still considering and working on the blood. We are still talking and working on blood. Uh, it is a tool to transport liquid, the red blood capsule. I'm saying it is a tool to transport liquid, and then the capsules are made so that the blood is drawn. They are made so then the blood is drawn to a 0.5 meter mark, and then diluted to the 101 mark, and the diluted will be 1 is to 200. The dilution should be 1 is to 200. Yes. This is the standard dilution. If the blood is drawn up to 1 mark and diluted to it marks to 102, it gives a solution of 1 is to what? 1 is to 100. What is happening is we are saying if the blood is drawn up to 1 mark and diluted to and it is diluted to 101, the ratio is 1 is to 100. This is just to say 1 is to 102, and then this has just been standardized to say 1 is to 102 can also be given as 1 is to 100. So the amount of blood is the amount or the ratio composition of blood is 1, and then we are saying then it can give us a ratio of 1 is to 100. The red cells peptides have red mixed bead and white cells peptides and white mixing bead. Obtain the blood by pricking the skin. Wipe off the first drop and draw the blood up in the peptide against the drop of blood, and turning the peptide sideways. If more than what is necessary is drawn, the excessive blood can be sucked out by tapping the point against the piece of the tissue paper. I'm saying according to the tool that you are using there. Therefore, you would find out that maybe excess blood has been drawn. Therefore, in that regard, uh, the excess blood can be sucked out by tapping the point against a piece of tissue paper, which is placed on the tool there. And then no air bubbles are allowed in the pipe date. There shouldn't be no air bubbles. The air bubbles are not allowed. Take note, this point is also quite often asked to say, why are there not supposed to be air bubbles in the what? In the pipe tight when collecting blood? The bubbles would cause unreliable results or would cause biased readings, because the amount of blood that is there is not exactly what should be there, because some space of the in the tube or in the peptide is occupied by air. So no air bubbles are allowed to avoid false readings, or in order to make sure that the very correct amount of blood is collected. And then wipe off the blood on the outside of the pipe tip without drawing blood out of the pipe. So no spills are allowed when you are cleaning the pipe tight. And then without drawing blood out of the peptide, that is avoiding spilling. By using the mouthpiece and rubber tube, red cells diluted fluid is drawn up to the 100 mark. So what is happening here is that when the blood is collected, the the red cells diluted fluid is drawn up to 100, up to 101 mark, which we have already illustrated in the example that we are talking about above there, to say that blood can be 100, can be at 1 mark, and then you have to take the red cells up to 101. up to 101 mark. So that is what is supposed to be understood in that respect. You understand? And then the leukocyte count. The leukocyte count, white cells, white cell peptides are made so that when blood is drawn up to 0.5 mark and diluted to 11 mark, a dilution of 1:20 is obtained. The procedure is the same as for red cells count, except that white cells diluted fluid is used and the cells are counted per are counted over the squares. So the calculation is done as follows. How is the calculation done? Is equals to total cells counted multiplied by 50 would give us the leukocytes per cubic milliliter. To say the total number of white cells counted multiplied by 50, it will give us the total number of leukocytes per cubic milliliter. That is the formula that you can use to say count the total number of cells and then multiply by 50 to get the leukocytes per cubic milliliter. The hemoglobin determination, that is 20 millimeters, 20 cubic milliliters of blood. This is 20 cubic milliliters, 20 cubic milliliters, 20 cubic milliliters of blood. These three must be there. 20 cubic milliliters of blood is added to hydrochloric and carefully shaken without forming air bubbles and diluted so that it corresponds with the standard, which has been the standard that we are talking about in the first part there. Then the quantity is read from the graduated thermometer and expressed in grams per 100 milliliters. Normal values, many have got a measurement of 14 to 18 grams, and then women has got 12 to 16. These figures are also the hemoglobin determination. We are saying the ratio or the measurement for men is 14 to 18 grams, and then for women it is 12 to 16. These are normally given also where it is true or false. So men is what, 14 to 18, women is 12 to 16. These sometimes you find them on what? On true or false questions. NB, check out on true or false questions. Where they will give you to say men are this measurement and women are this measurement. So the thing is, the men's measurement is just that, which I'm giving you now, that it is what? It is 14 to 18. And then for women is what? Is 12 to 16. Those are the measurements that you should not miss out. Okay. Differential counting. Differential count. I'm sure if you look on your part A of your question paper, you've seen this question quite a lot of times where they say define the term differential count. Define differential count. So it determines the percentage amount of each white blood cell present in the blood. It can also detect immature white blood cells and abnormalities, both of which are signs of potential issues. Differential count, it defines the percentage amount of white blood cells present in the blood, the total number of white blood cells present in the blood. It's also is defined as what? Differential count. It can also detect immature white blood cells. Those which are not yet mature can also be counted there. And abnormalities of both are also potential signs that must be checked on. And then is the expression of the different types of white blood cells on percentage basis. Expression of different types different types of white blood cells on percentage basis. That is the differential count. It determines the percentage of each type of white blood cells. The percentage of each white blood cell is calculated or is defined as differential count. Each type of the white blood cell is counted in different fields with differential counter until a total of 100 hemoglobin has been counted. So different types of leukocytes. We have got monocyte. The different types of leukocytes. We have got monocytes. We have got we have got the lymphocyte. We have got the eosinophil. We have got the basophil as well. These are different types of leukocytes. Let's just continue. The next question part is saying the hematocrit. The hematocrit is a method to determine the percentage total. The percentage total the percentage total of the total percentage total blood cells which are represented by packed cells after it has been centrifugated. So what we are saying is that the hematocrit, it is actually a method used to determine the percentage total blood cells which are presented by packed cells after it has been centrifugated then. So what is happening there is that you must understand to say it is not the difference between it hematocrit and what hemoglobin and so forth. The next part is erythrocyte sedimentation speed. I'm sure you've seen ESR in quite a lot of papers in your books there. What is ESR? Sometimes they even give it as an abbreviation to say state, give the expand the acronym ESR. What does it stand for? It's what is erythrocyte sedimentation speed. Is the rate at which red blood cells in anticoagulated blood descend in a standardized time over a period of an hour. The rate at which the red blood cells in an anticoagulated blood, that is blood that is fluid, that is not clumped blood, when blood has not formed clumps, the rate at which the red blood cells descend in a standardized time, how the speed at which the red blood cells descend or move down in a standardized time over a period of time of an hour, to say when blood is left fluid as it is, the rate whereby the red blood cells are going down over a period of an hour, we call that what erythrocyte sedimentation speed. And then it is necessary to draw blood from a vein to obtain. It is necessary to draw blood from a vein to obtain enough of this test. I mean, enough for this test. That is to say, when enough blood is drawn, the rate at which the red blood cells are sedimenting or are descending down can well be checked. The blood must be drawn in the middle of the vacuum container which contains the anticoagulant, so that the blood does not clot. The blood must not clot, must not form clumps. So it must be drawn in the middle of the vacuum container. And then the anticoagulants must be put in the blood, so therefore it cannot clot, in making sure that it remains fluid. It remains liquid. When it remains liquid, therefore the red blood cells can be able to be checked, the rate at which they are moving downwards. The normal ESR for men is 0 to 9 millimeters per hour. That is the rate at which the red blood cells sediment or the rate at which the red blood cells descend for men is 0 to 9 millimeters per hour. And then the normal for women is what? 0 to 15 also per hour. So this one, you find it on what? True or false questions. As to say, what is the rate for blood segmentation for what? For men and for women. True or false question. So you must know that the segmentation speed of red blood cells for men is 0 to 9 and for women is 0 to 15. Implication for this test of the segmentation rate: increase concentration of fibrinogen and various globulins in the plasma, and then any microbic infection leads to increased immunoglobulin, which the ESR will increase. So what we are saying is that the results of the ESR test, it shows increased concentration and also the various globulins in the what? In the plasma. As to say, the blood plasma, those are blood fluids, which are the fluid water-like substance that is found in the blood. And also it also shows any microbic infection that leads for increased immunoglobulin, which will be increasing the ESR. That will be increasing the ESR. And then it also shows the erythrocyte segmentation speed. It also identifies the protothrombin, determines how fast one's blood clots. And then we also have the blood counts. It's also they can also be seen through the ESR test. The hemoglobin test checks for anemia. It also checks for anemia there. The COMS test. COMS test detect antibodies stuck to the surface of the red blood cells. And the Russell specter test for anti-immune hemolytic anemia as well. So what we are saying is that COMS test detect antibodies stuck on the surface of the red blood cells. And then the Icterus index. The Icterus index shows the amount of the bilirubin in the blood, how much of it is in the blood. The blood glucose also, I'm sure you know the implications of blood glucose if it is not well balanced, resulting in what? In chronic illnesses such as diabetes. The hematocrit percentage of the red blood cells, I'm sure that we have already also talked about this, as to say the hematocrit is the percentage of red blood cells. So please, class, take note of this and don't make mistakes. I hope that you are going to use these notes for your readiness for exam. Thank you very much for watching, and I hope that you keep on following for the next recording that is coming soon